So in part one of this video, we learned how to convert current and time into charge, and we learned how to change charge into moles of electrons. So in part two, we're going to put it all together, and we're going to ask ourselves, if we're running an electrolysis experiment for a certain time, what mass can we make? So for instance, here's a problem. If we electrolyze sodium chloride, okay, for say 3 hours at a current of say 30 amps, then what mass of sodium and chlorine can we make? So this is a typical electrolysis problem. So what are we on about here in electrolysis? We're taking a molten salt, so you can think of it as made of ions on the inside, and we're taking that molten salt and we're turning it into the elements, so sodium, which I guess it'll be so hot it'll be molten, and chlorine, well, it'll be a gas anyway. It is a redox process, so we essentially have got two sodium ions changing into two sodium atoms, and we can balance that by putting two electrons on the left, so that is reduction. And we've got chloride, we've got two chlorides going to chlorine. To balance that equation, we need two electrons on the right-hand side. So those are our processes here. We want to know what mass of sodium and chlorine. So first off, you have to know the reaction. So we're basically taking the compound and changing it into its elements. I'll give you one here in a minute. And then we're going to do some stoichiometry. So here's the fun part. So we're going to start with a definition of current. So we know current is charge over time. We're going to rearrange and say that charge is current times by time, and we're going to calculate the current that flows. So that is 30 amps. So 30 amps, that's a coulomb per second, times by the time. That was 3 hours. Actually, let me make it 3.00 hours. That's okay. Just don't want to throw away too many significant figures here. We know that an hour is made up of 60 minutes, and we know that a minute is made up of 60 seconds. So we can go ahead and we can calculate the number of coulombs of charge. So if we do that, we get a very big number, 324,000 coulombs. Now, here's the plan. So we're going to convert that to moles of electrons, and then we're going to convert those to moles of sodium and moles of chlorine, and then we're going to convert those to grams of sodium and grams of chlorine. We haven't done this for a while, so this is a little bit of stoichiometry practice. So let me move stuff up. All right, and I'll do this one step at a time. So step number one here. So I'm going to start with 324,000 coulombs of charge. I know that the Faraday constant tells me that there is 96,500 coulombs of charge per 1 mole of electrons. All right, so now we got it in moles of electrons. So how do we relate that to moles of sodium? Well, we know that 2 moles of electrons make 2 moles of sodium. So we can go ahead and write that relationship there. So 2 moles of electrons, 2 moles of sodium. If we stop there, we get moles of sodium. So if we want grams of sodium, we just have to look up the atomic weight of sodium. The atomic weight of sodium is 2299. So there's 22.99 grams in a mole, and that gives us 77.2 grams of sodium. And maybe you can pause the video and try the same thing for chlorine, and then we can compare notes. All right, so same thing for chlorine. So 324,000 coulombs of charge. And we can change coulombs into moles using the Faraday. So 96,500 coulombs is a mole of electrons. And for chlorine, we can see that 2 moles of electrons are needed to make 1 mole of chlorine. So that's that 2-to-1 ratio there. So we write 2 moles of electrons, 1 mole of chlorine. And then we need to figure out how heavy a mole of chlorine is. So we can look up the atomic weight and double it. And we get something like 70.91 grams per mole. And if we go ahead and plug that in, we get 119 grams of chlorine. That was pretty cool, right? So by electrolyzing salt, we can turn it into sodium and chlorine. And that's certainly one way that we can manufacture both those elements.